So I'm sitting here with Frans our founder, and that's so obnoxious.
Okay.
Former CEO who's busy looking up the definition of semi-supervised learning. We started to record this, well, actually like 10 days ago, but that sort of was aborted because Frans couldn't pronounce the name of the author of the paper we were talking about. So I'm going to put this all in Frans. Although, I mean, it's not really fair because I actually didn't even finish the paper personally, which was very much against the spirit of our journal club. So this podcast hopefully will be the first in a series about the DataProphet journal club, mainly. We've got a journal club. It happens more or less regularly. We've been doing it for years. The point of the journal club is to have just free-ranging discussions among whoever's interested about the sort of theory behind some of the machine learning that we do or don't use. So, I mean, the idea is not to do research for our projects, for customers. It's to just to explore more than to exploit, right? And we had an idea just to share some of that, I guess, partly to kind of share what our what kind of motivates us, what it's like in DataProphet, you know, I suppose kids at university doing computer science at UCT or WITS or whatever would be interested in seeing, you know, some of what's going on inside some of the AI labs in South Africa. And yeah, and maybe someone wants to join our journal club. What we do, I think, very occasionally get an outsider, and certainly they'd be welcome to join. Anyway, so we, in our last journal club, had a discussion about a paper that Frans brought forward. And Frans, do you want to introduce this paper and get the author's name right this time, please?
Thank you. Thanks, Joris. So the author of the paper is Jürgen Schmidhuber. The title here is Driven by Compression Progress. A simple principle explains essential aspects of subjective beauty, novelty, surprise, interestingness, attention, curiosity, creativity, art, science, music, jokes. That's, I think the author himself as a name, if you've looked into machine learning, you'll recognize that name. You know, he's authored over 400 papers in this space. He focuses entirely on machine learning. You know, and he's published papers that have introduced fundamental techniques. I'm not going to use the word techniques because I think that's important. Such as LSTMs, recurrent neural networks. Kind of in his author page, he also talks about the fact that he contemplated or introduced the idea of pre-training and transformers a couple of decades back, right? So he's certainly very important in the machine learning space, and it's very interesting to see him you know, publish this type of paper, which I think is a bit more esoteric when it comes.
Yeah, and it's good, I guess, to talk about him. I hadn't heard of his name yet. He's one of the founders of modern AI. So that's good. And then I'm curious, like, I don't know if you know where he currently works. Is he more of an engineer, more of a fundamental kind of mathematician?
Yeah, I forget the specific institute he attached to. Originally Swiss, runs an AI lab, right? Contributes quite widely.
Okay. So it's a commercial AI lab.
As best I'm aware, it's actually an academic,
cool.
or at least a research-focused.
Yeah.
So the lines between commercial and research versus academic research are very blurred.
Yes,
right?
this is true.
That just, you know, still publishes work. So I think for all intents and purposes, still part of the open research community.
Yeah. Cool. Do you want to tell us about this paper? You said, you know, it's a relatively, I mean, compared to some of our other papers, it kind of comes across initially as a bit zany. Yeah, yeah, do you want to introduce the paper?
Yeah, I think for anyone who's got a background in mathematics or statistics or machine learning more generally, the title of this paper is going to make you feel a little bit uncomfortable because it's a set of topics that you don't usually address using mathematics or machine learning. So it was very interesting to see him talk about this. I mean, it's published back in 2009, so it's not a new notion. And if you delve into, I guess, some of his own writing about himself, does, as a hobby, does look to try and understand fundamental aspects of the world, right? And here is a paper that, takes a lot of the concepts that we understand, compression, reward functions, error functions, and kind of characterizes it in more general learning systems, of which, people are one of those, right? And so, here is trying to characterize, I guess, our experience of beauty, and I think he focuses a little bit more on interestingness as a learning system, right? In a framework, an algorithmic framework that would allow us to, rebuild it, right? Or kind of build it in some pattern, and it's very interesting, right? Like, I think reflecting on our conversations in the journal club, that expression of discomfort initially, but then in reading a little bit deeper into it, made comfortable with some of his assertions, was repeated, right? And even in the author's own writing, he flits through subjects and says, look, I don't want to delve too deeply here because it might be a bit controversial. For example, consciousness. He's got a very nice title. Yeah, consciousness as a particular byproduct of compression, where he says, look, a learning system that has to compress the world, it's useful for that learning system to have an idea that it exists in the world. And as a result, you get consciousness. But he quickly escapes out of that paragraph to say, it's, they don't want to attach any particular mystic value to the notion of consciousness. And so that conversation is not going to feature any further.
Right. You mentioned sort of he's looking at these fundamental, kind of almost philosophical kind of perceptions of what the nature of intelligence is, in order to rebuild it, I think was the phrase you just used.
Yeah.
Obviously relevant to mention this paper was published in 2009.
Yeah.
Do you see any references recently to this paper in terms of looking at, obviously, the whole debate about the nature of intelligence is kind of alive right now? Or are there any other things you have in mind when you say, looking at rebuilding?
No, I think it was more this discussion, this paper, to kick off a series of conversations on machine learning in our journal club. Forms a nice foundational block, right? And when I talk about kind of the algorithmic application of it, you could use this conversation here to evaluate some of the techniques that we're applying today.
Yeah.
Right. Like in this, we talk about rewarding improved compressions as a intrinsic or a kind of reward function that would feature maybe earlier than the final reward of whatever the agent is trying to achieve, right? And so that as an idea is often used in the likes of reinforcement learning that has, long-term or long horizon results. And so in the intermediary steps, it's got to have some reward function to guide it as to whether it's improving or not.
Yeah, tell us about the sort of shorter term reward function that is kind of put forward here.
Yeah, so he defines beauty as or things being more beautiful if they have a smaller number of bits that can kind of represent them, right? but that in the learning system, which also then it includes the learning system's ability to compress bits in it, right? So it does then immediately make beauty subjective, which I think everyone's kind of quite comfortable supporting, right? Each has our own learning system. But he defines beauty as what is the smallest number of bits that can represent it. And so things that are more regular, so symmetrical faces, as an example cited here, are more beautiful because they're easier to compress and reflect in a smaller number of bits. Right?
Is his conception of beauty subjective? I know that his conception of interestingness, which is sort of the
First
process
derivative
towards
of-
beauty,
yeah.
is subjective because obviously it's a function of your current state in terms of your ability to compress.
Yeah.
But is that right? So beauty itself too is subjective, i.e.,
Well,
it's a function of your ability to compress something's beauty to you. I suppose if you can't compress it, then you don't see the beauty.
yeah. So if the learning system, if your compression algorithm that you're running can't compress it because you can't see the regularity in it, then you won't see it beautiful. And I think the nice conversation we had in our journal club is actually kind of characterizing it in classical music, right? Whereby individuals who have had a lot of training in classical music will better appreciate the beauty of classical music because their learning algorithm already has a good compression for that musical piece. Whereas those who aren't trained in it won't see the regularity in that classical music and so subsequently won't see the same beauty in it.
It'll sound more like noise to them.
Yeah, it does pull out the idea to say, look, there are different types of beauty, and we overwrite that word horribly in English, and I suspect most other languages. But he's talking about this idea of more pristine beauty as opposed to beauty that's rewarded by, has some kind of evolved reward function already in humans.
So he makes a few controversial statements. I mean, one of them I was just looking at now is, he says, in particular, we reject the traditional Boltzmann/Shannon notion of surprise, which is quite a statement.
Yeah.
He's saying he literally rejects the Claude Shannon's notion of surprise, and I suppose the whole sort of definition of information entropy that it's related to. Do you think that's just him rage baiting, or is he being?
I don't know. Maybe he does like to rage bait, but I wouldn't. I don't think it necessarily to reject. He's separating out the idea of surprise and interestingness. And already, we've got two different words then, right? Where the Boltzmann and Shannon are talking about white noise as the most amount of information.
Most amount of surprise.
Yeah, most amount of surprise. And he's saying, well, there's no way you can compress it, and so it is not interesting at all, right?
Yeah.
And that's him rejecting it, right?
He does reuse the term surprise as well. I just wonder whether he couldn't have, complimented more than overridden.
Look, I mean, maybe it's his controversial nature. Again, he's renowned for calling out people for not properly attributing work, and not a bad thing.
But Shannon, obviously, not one of those people who's failing to attribute things. I mean,
no, right? But, I mean, the controversial disposition might be just come naturally.
Obviously, we're gonna keep this first episode a little bit short. We've got every Monday we have a little town hall at 9:30, and our hard stop is going to be when people come flooding into this boardroom. After the town hall, we've been excused by our CEO from joining this morning. But is there anything else you wanna sort of highlight from this paper?
No, again, it's a wonderful foundation for the set of journal clubs that we're about to embark on, which are more concerned with fundamental theorems and limits and axioms than techniques. Right? And this was nice and easy to read, and I think it's approachable by anyone. Don't need a background in stats or maths. And it's very well written. Like the author writes particularly well.
Yeah.
It serves kind of as a launch pad for our conversation of more fundamental techniques, right?
Yeah. So we're going to do a little series. You've kind of proposed this. Obviously, past things we've spoken about. We've spent a lot of time in Journal Club looking at the transformer architecture, looking at things like
these are all techniques, right?
They're all techniques, yeah.
I think what we've done in our preliminary research, the set of fundamental limits or theorems that govern machine learning are actually, there's quite a small set of them, right? And of course, they're very useful to help evaluate the competence of the new techniques. And oftentimes techniques which come with results drown out kind of the nature of the theory behind them, right? Although techniques themselves typically are not very long-lived, right? They last as long as the next one that comes along and unseats it from whatever benchmark it's been sitting on. Right.
Sort of internal combustion engine kind of vibes.
Yeah. It's like, I guess we keep changing it, right, until as we get better and better ones.
Yeah, that's cool. So I think it's a nice little discipline and kind of mental, intellectual hygiene, so to speak, to kind of go back to these fundamental concepts. And yeah, it's going to require some discipline, I think. Actually,
so I think we've all seen a lot of techniques come and go.
Yeah.
Like in the 10 years we've been working, there's been the flavor of the year.
Yeah.
And whether that's gone from LSTMs, recurrent nets, convolutional nets, LSTMs, adversarial nets, dropouts, capsule networks.
Makes your head spin.
There are more techniques than we can count in this period. And right now, of course, transformers and LLMs are having their run, right? But it's going to keep moving.
It's actually an interesting meta discussion. I mean, it's a bit of a kind of somewhat random exploration. The sort of seeing what sticks. Let's try this. What about if we do this? I guess often driven by some intuition, but particularly driven by maybe something a bit like this, where the engineer in question, who is probably very bright, probably somewhat competent both in engineering and in the theory, they have an intuition that if I did this, then I would overcome this problem I'm facing. It's sort of trying to climb out of or into some local minimum in terms of their results. And it's, I guess, interesting. It just occurs to me now, like, a lot of people are talking about how LLMs are going to help recursively drive progress. And in a way, I suspect LLMs are going to be sort of supercharging that type of exploration, which isn't especially fundamental, maybe.
I mean, I think it's also relates to our conversation on inductive and deductive reasoning. And right now, all our techniques, we're just kind of inducing out of this experience of, having that intuition, implementing, getting a result, demonstrating that it's better, right? But there's no deductive reasoning in this, right? I mean, there's suggested deductive reasoning.
I get as confused about those terms as I do about
pre-training, semi-supervised,
accuracy,
precision recall, specificity.
I have to learn the matrix back into my mind. Luckily, we don't seem to have to think too much about that anymore. I suppose it's because of our...
The
nature of our work has kind of changed in the last 10 years, where we don't spend a lot of time talking about sort of the accuracy versus the specificity, etc., of our models.
I mean, it's an ongoing conversation. Even some of the customers I'm working with now.
Yeah, it might just be a reflection of the fact I'm no longer in the data science team.
We had this conversation last week with a customer where we've given them an accuracy number, but we've told them that the relevance of that number is actually not important. What you want to know is, recall or precision or some version of those.
To lean a lot on the receiver operating characteristic, which was not. I don't know if that was that useful to speak about to the customer.
No, it is. But you've got to, depending on the customer's familiarity, you've got to spend a bit of time with it.
Yeah.
because it's the more honest way of conveying what the the binary classifier is doing.
Yes. And obviously different whether you're speaking to someone with a stats background in the insurance industry versus someone with an engineering background in manufacturing.
Yeah.
Sorry, I've gone on a bit of a tangent there, but I do think it's funny to think of the discussions right now about, people talk about takeoff and things. So I'm going into the more sensational topics.
Okay.
People talk about takeoff, whether it's the sort of CEO of Anthropic, on the basis of this whole idea of kind of recursive improvement or of these models. I guess Anthropic are promoting this idea with statements like most of the development currently of Cloud Code is being done by Cloud Code.
Yeah.
But I suppose what we're trying to do in the next few iterations of the Journal Club is kind of an antidote to this sort of random walk of improvements, and I can go back to, okay, what do we know? What are statements in the theory, and let's remember what sort of pillars we're standing on. Yeah,
and how helpful are they? It's like I think the body of theory goes around machine learning is quite. There's not a lot out there, right? In terms of kind of fundamental learning theory.
Yeah.
But there's like, even in this, it'd be helpful to characterize LLMs in the context of, say, the no free lunch theorem, to say, well, no one thing is best at all things, and so let's not fall into that trap. Right?
Are we gonna have a journal club meeting on that?
Yeah, okay. I mean, no free lunches, the theorem's wonderful when thinking about these things, and there are other elements as well. It's like I'm curious as to what is the limit to inductive learning in terms of and there are ways you can characterize it in kind of information complexity, or the amount of information in the data, or there's a mixture of fundamentals there. But it's also to say, well, what can inductive learning, what can't inductive learning learn, right? And in all of these discussions, pull apart, what's going on. And what I mean by that is, of course, large language models currently dominating, but they're all inductive learning, supervised learning type processes. And meanwhile, you've got these labs doing very good work in reinforcement learning. Yeah. You've got the reinforcement learning practitioners and theoreticians petitioning to say, look, your supervised learning will hit a hard limit. And of course, all of the naysayers or the hyperbolists trying to claim that large language models will lose their supremacy very soon, or immediately, or right now, or 10 years ago. And then so to understand the veracity of all of those comments and delve into them a bit deeper. Yeah, I look forward to this. I think we're probably out of time now. I'm going to look at your... let's give ourselves 5 minutes before the day starts. Okay. Thanks for the chat. Cool. And I look forward to this series. I'll try and read more than half of the paper next time. See you guys next time.